everyone, so in the second part of differentiation we are looking at the rates of change and then we're going to move on to integration. So for a rate of change, the rate of change of a quantity A is the derivative of A with respect to time, dA dt. When you see dA dt, you can think of d as being a difference. So it's a difference in the quantity A over a difference in time, and that's how we measure rates. Think of all the rates you know. Let's say speed is difference in distance over time, kilometers per hour, for example. If you're downloading something from the internet, it's megabytes or whatever it is per second. So it's a change in some quantity over time. So think of dt as your denominator, a difference in time. Now, if the quantity is decreasing, dA dt, the derivative will be negative, and sometimes you're the one who has to introduce that minus sign, So if you're told the quantity is decreasing, you know therefore that the derivative should be negative. Okay, so for example, if water is dripping out of a tank at a rate of 2 milliliters per second, that's volume over time, then the change in volume over time, dV dt, is minus 2 because the quantity of water in the tank is going down. Okay, and then velocity, and just one other thing with the related rates of change questions, you often have to use the chain rule. And if, for example, you wanted to relate dA dt, maybe a change in area, to some maybe change in radius, make sure that these line up. So dA dt is dA dt, and then introduce your dr. Okay, that's your chain rule. Velocity and acceleration. If s of t is the position of a moving particle at time t, if you take its derivative, if you take its derivative, you get ds dt, which is the velocity of the moving particle or the speed of the moving particle. And if you take another derivative, you get the acceleration. So the acceleration is dv dt, but it's d2s dt squared. It's two derivatives away from the position, okay? And then going back upwards, because integration is the inverse procedure of differentiation, you can integrate the acceleration to get velocity, and you can integrate the velocity to get your position. Just be careful when you integrate. Remember, it's a little trickier because you have to add your constant of integration c, and oftentimes you have to solve for that constant. So they might tell you the velocity, the initial velocity is a certain value, and the initial velocity would be the velocity at time t equal to 0.